Okay, I'm Brian Clapper. I'm a independent consultant. I run the Philadelphia area Scala user group, and I teach Scala and Play and a few other things for NewCircle. And today, what we're going to talk about is a feature of Scala that I think is one of the killer features. It's one of the most interesting capabilities in the language. So those of you coming from a Java background might find this particularly interesting because even with Java 8, there's nothing like this in Java. So we're going to start talking about something called apply and update. This is a setup for the cool feature that we're going to be talking about. Scala permits you to make anything callable as if it were a function. So if I've got a class or I've got an object, if that object has an apply function on it, then I can call it as if it were a function. So for instance, if you look up here on the slide, here we're calling something called f, and this looks just like a function call, exactly like a function call. But really, what Scala does is it looks at that and it says, is f really a function? No, it's not. Okay, does f have an apply function? If it does, then it maps this call into an apply call. All right, so that's if you call it in this fashion. It also permits the function call to appear on the assignment side of an equal sign. So in this second instance here, it looks as though we're assigning some value to a function call. But really what's happening is Scala desugars that, and that's the term we typically call, is desugaring. This is syntactic sugar for this f.update call. So it calls f.update, and it passes in the arguments that you give it over here on the left, followed by the value. Now where this is typically used, a very common example is we're updating a map or an array. So this next example down here shows that we have created a mutable hash map, which corresponds to a typical Java hash map. And now we're going to assign the key Bob the value 100. And because of the update syntax, we get this natural assignment right there. Okay, we don't have to say scores.put. We don't have to make any weird function call. We're just saying, hey, assign scores sub Bob the value of 100. All right, so far, nothing really slick about this. I mean, it's kind of nice the compiler does this for you, but you know, of what value is this? All right, so the one use for the apply method is typically in what Scala calls a companion object. Whenever you create a class in Scala, so here's an example of a class called fraction, you can create what's called a companion object. Now, an object, for those of you not familiar with it in Scala, is a singleton. It's kind of like a static class is in Java, but it isn't really a static class. It truly is a singleton. So if I put an apply method on my companion object fraction, note what this apply method does. This apply method basically says, you're going to give me a numerator and a denominator, and I'm going to create a fraction for you out of that. So this allows me to create new fraction objects without the use of the new keyword, which is kind of nice because this leads to a little bit more of a readable syntax when you're stringing a lot of these things together. Looking down here, instead of saying new fraction 3 comma 4 star new fraction 2 comma 5, the new in that would be is kind of visual noise. You don't really need it. So the apply method allows us to call these things and create them without needing the new. So that's one advantage to this. And again, this is all lead into the cool feature. So we're not to the cool feature yet. Where we're going with this is something called unapply. So just as there's an apply method, Scala also has this idea of an unapply method. So think about an apply method as taking a bunch of discrete parameters and assembling them into an object. That's the typical use of it. So what's the reverse of that? I have an object, and I want to disassemble that object into those original discrete parameters. That's unapply. So for instance, unapply is used for what Scala calls extractors. And this is an example of an extractor. Here I've got a fraction, 3/4 times a fraction, 2/5, and I can do that because of operator overloading, something we're not going to talk too much about right now. And then on this side, I'm assigning it to fraction AB. And what Scala desugars this into is basically fraction.unapply of the resulting fraction. And so the bottom line here is that this var, this statement right here, pulls out A and B automatically. It extracts them right out of this fraction. Subsequent to this statement in the code, I can now refer to A and B without having to assign them anywhere. They're extracted right out of the fraction into local variables. Where this is most commonly used is in a pattern match. And pattern matching is where we're going with this. Pattern matching is the whole point of all of this, is so that we can talk about this. So how do I build an unapply method? Basically, this is it. It goes on the companion object. We put def unapply, and here's the input. The input is a fraction in this case. So we're unapplying the fraction. We're going to be taking the fraction apart into its pieces. Now, in order for this to work properly, we have to return an indication of whether or not we were able to find something to extract. So what we're saying here is we're going to return an option. An option is none, meaning there's nothing there, or some, which contains the result. So in this case, we're returning none if the denominator is 0. It makes no sense to pull apart a fraction if the denominator is 0, because that's an illegal fraction. You can't divide by 0. So if for some reason somebody's constructed a denominator of 0, this extractor is going to return nothing and fail. So we return a none. Otherwise, we're going to return the pieces in a Scala tuple, which is a read-only heterogeneous collection. So here's the input numerator and the input denominator collected up in a tuple and then wrapped up in a sum, which is the opposite of a none. This is all you need to do to build an unapply, and as soon as you do that, you can start doing pattern matching stuff on this. And we're going to look at that in just a moment. So the key here to remember as we start talking about pattern matching is apply and unapply. They are cool, they are key to doing pattern matching in Scala. All right, we can have extractors with multiple arguments. So here's an unapply that takes an input of a string. So the problem is that Scala doesn't provide the ability to do a one tuple. It has 2 tuples, 3 tuples, 4 tuples. What if my extractor is only extracting one thing? Well, the answer there is there's a special case. Don't put it in a tuple. Here we're returning an option of a single integer, not an option of a tuple. So we're going to try to unapply a number by parsing the string that you give it. And if that fails, we're going to return a none. We're going to catch the exception, return a none. So in this case, the sum does not include a tuple. The sum just includes the thing that we're trying to return. And with this in place, I can then do something like this. Okay? Val number n is equal to this string, and n will be set to the value of that number if the parse succeeds. Okay? And again, this is just an example. This is not the common use case of this. The more common use case is something like this, where you use it in a pattern match. So let's keep moving. There's one more piece that we need to look at, and that's called unapply seek. Unapply is intended to pull out always the same number of things. So in the case of fraction, we always know we want to take apart a fraction into 2 pieces, the numerator and the denominator. But what if we want to take apart something that is of indeterminate length, like an array or a list, some kind of a sequence? In that case, we can't use an unapply, because to take apart an array, I might be taking apart something that has 1 element or 15 elements. So in that case, Scala looks for something called unapply seek, seek being in this case shorthand for sequence. So we call it, if we do an unapply seek, we provide that capability, then we can allow an indeterminate number of matches. So this match down here, for instance, take apart a name. If the name contains 2 elements, a first name and a last name, I want to run this case match. If the name contains 3 elements, a first, middle, and last, I want to run this match. If it's a certain kind of Dutch name, so that the first element is captured here, followed by the string van, followed by the string der, and then followed by a last name, like James van der Linden or something, then it will match this case. So in this case, the unapply seek allows us to do an indeterminate level of matching. All right, so that's the background. And with that background in place now, we can start to talk about pattern matching. So now we're to the cool part. Pattern matching in case classes. Pattern matching is sort of like a better switch statement. Okay, those of you coming from Java or C or C++, you're used to the C-style switch statement. When you switch off of a value in those languages, that value has to be integral. It has to be a number of some kind. And characters count as a number. They're a small number stored in a byte usually, right? Or in the case of Java, stored in a 16-bit UTF-16 representation, but they're still integral. So you can think of the pattern matching as sort of like a C-style switch. So if you look at this example here, this doesn't look much different than a switch in Java or C or C++. We've got a character, and if it matches a plus sign, then we're going to run the first case. If it matches a minus sign, we're going to run the second case. If it matches anything else, and the underscore is sort of the default case, then we're going to run the last case. Now, there are a couple differences here that you don't see in Java. There's no break statement here. There's no fall through. Okay, so case matches don't fall through to the next one, so you don't need to have a break statement. They don't work that way. When a case is matched, the code next to that case gets run, and then the match is done. All right, so we can, because this is Scala and every expression in Scala has a value, we can take the result of this match, which is an expression, and we can assign that to a val. So if I don't want to use, like up at the top here, I'm actually assigning it to a var. Well, we don't like to use vars in Scala. We like to use immutable variables. So that's okay. I can just do it this way. Run the match. Each case ends with an expression. These expressions then, whichever one fires, that'll be the return value of the case, the result of the case or the match expression, which we can then assign to sign. And we can match any type. Okay, this is where we start to stray away from Java. We can match with any type at all, not just numeric stuff. So this is an enumerated type called color. I can match against the colors. But even more interesting, I can match against, I can add guard statements. Okay, so typically in C, if I want to match all the numbers, I'll have multiple cases, and because these cases fall through if there's no break statement, then no matter which one gets matched, 0, 1, 2, etc., up to 9, it'll fall through and run the code associated with the 9 because of the fall through. Without fall through, we can't do this in Scala, but what we can do is the following down here. We can say, okay, if it matches a plus, set the sign variable to 1. If it matches a minus, set the sign variable to -1. If it's any other character, as long as it's a digit, so this is a guard condition, case, anything, but only if the character is a digit, run the digit code. Otherwise, and that's our otherwise at the bottom. So these guard conditions then allow us the same flexibility with a different syntax. And that guard condition can be any Boolean expression at all. Okay, now the other thing to note here is that patterns are always matched top to bottom. So if there are two patterns that happen to match the same thing, the first one wins. All right, now let's continue because this gets even more interesting. Here's a case where I can actually use a variable in the pattern. So I can say, does string sub_i match a plus? Do this. Does it match a minus? Do this. If it matches anything else, though, I would like to capture that anything else in this ch variable so that I can do stuff with it. Okay, this is also something that cannot be done very cleanly in Java, if at all. All right, so I can use the variable name even in the guard. I can add this here. If it matches anything else, but if that anything else is a digit, so now I've captured that character here and I'm using it in the guard condition. Okay, so there's more to this though. I can use this to deconstruct types. This is one of the cool things that you can do here. This is why in Scala we never use the equivalent of the instance of operator that we use in Java. In Scala, I can just do this, object match. All right, is it an integer? Well, then capture its value in x and do something with it. Is it a string? Capture its value in s and do something with it. Is it anything that's a big integer? In other words, if it's a big integer, I don't want to capture the value. I just want to return int.maxValue. And if it's anything else, return a 0. I can decompose types in this pattern match capability. This is really, really useful, and it's a heck of a lot more readable than a bunch of cascaded ifs where you say, hey, if obj is instance of this, else if obj is instance of string. This way, you've got a nice little table that decomposes it. Now, the one thing you can't do is this kind of thing. You can't decompose generics like this. I can't say, hey, is this thing a map of string to int? You can't do that. That won't work because of a limitation in the JVM. It erases these generic types, so you don't have the option, you don't have this information. It's just simply not available. This won't work, but you can match a map and say, look, I know I can't look at the map's generic types, but I can still match a map. So you can do that. It gets more interesting than that, though. This is where we get back to our extractors. Okay, so now what we've seen so far is the ability to use the match capability to do standard switch style stuff. And we've seen that it also allows us to do reflection. We can determine the type of the thing that we're looking at. But when you throw in unapply and unapply seek, now you can begin to do things like what we see on the screen here. So I have an array. I want to do something to this array depending on the shape of the array. So here we have an array, and we're saying, hey, look, the first case says, does this array match an array with a single element that has the value 0? That's a very specific match. Does it match an array that contains one element and that element has the value 0? If so, the first case fires. The second case fires if the array matches an array with two elements. So case number 2 here, array XY, says that will match if the array passed into the match has two elements, and then we'll capture those two elements in X and Y. We will extract those two elements out of the array. What's happening is unapply seek is being called on the array, and if it matches, those two elements come out. They come out and they end up in X and Y, and now we can play with them. The third match basically says, match any other array, but it must start with a 0 and have any number of elements afterwards. So that underscore star is sort of a magic incantation that says variable number of things matching. So the third case will give us an array that starts with a 0 but has multiple things after that. And then we've got our fall through at the bottom, the case underscore. So, and it's always good to have a fall through. If you don't have a fall through, you'll get a runtime error if something doesn't match any of the cases. Other things that we can do are lists have a special syntax for extraction. They use this thing called a consing operator, but basically what this means is think of this as a list constructor. Nil is a special constant that means empty list. So if I'm matching a list type, I can use this operator and I can say, does it match a list that begins with 0 and has nothing after it? Then run this. Does it match a list that starts with X, is followed by Y, and then followed by the empty list? Well, this is a list of two elements, so I want to capture X and Y and play with them. Does it match a list that starts with 0 and then has a list, the remainder of the list after it, which I'm capturing in tail? Then do this, otherwise do this. So this is the same match for a list as the array match is up at the top. All right, and then finally, you can even do this same deconstruction with a tuple. So let's say I have a 2 tuple. This may be a 2 tuple of integers. Here, is this, does it match a tuple where the first element is 0 and I don't care what the second element is? Yes. If so, run this case. Does it match a case where the first element is something, which I'm going to capture in Y, and the second element is a 0? If so, run this case. Otherwise, neither one is 0, run the final case. Okay, so now we're getting into a really powerful abstraction. You can use this for so many different things in Scala. So we've seen how we can use these patterns to match arrays, lists, and tuples, but it gets even better than that. Regular expressions provide their own unapply seeks and unapplies. So I can do something like this. Those of you who've used regular expressions are familiar with this parenthesis construct in here. It's a matching group. It doesn't contribute to the pattern match, but it says, look, if this pattern matches, then extract the matched pieces so that I can get at them later. So this says, if this regular expression starts with any number of digits followed by a blank, followed by any number of lowercase characters, then the whole regular expression will match, but the digits will be captured in group 1, and the lowercase characters will be captured in group 2. And almost every regular expression library out there both supports this and then provides the ability for you after the match to say, okay, give me group 1 and group 2. But because Scala has this unapply and unapply seek and this pattern matching capability, they've implemented the Scala regular expression class to allow you to deconstruct it in a more readable fashion, so that I can say, take this string 99 bottles and match it against this regular expression pattern. If it matches, then extract group 1 into num and group 2 into item. This is much easier and much more natural. And you can see how this would be very useful for building complicated parsers. It makes this sort of thing very, very easy. We can use these patterns in variable declarations as well to deconstruct things. So I can deconstruct a tuple into its constituent elements by just doing this kind of a simple assignment. And it's the same sort of extraction that's going on. I can also, big int has this nice operator. Other languages refer to this as the div mod operator. So if you divide a big int by 10, if you divide big int of 10 by 3, you're going to get a quotient and a remainder. Well, this operator returns them both as a tuple, which I can deconstruct in one statement like this. This is similar to, you can do this in languages like Ruby and Python. And it's a very clean and very simple and very readable syntax. Unfortunately, you can't do it in Java. So this also allows me to do something like this. I have an array. I don't know how long this array is, but I do know that it has at least 2 elements in it, and I want those 2 first elements, and I don't care about the rest of the array. I can use this syntax to extract it, to break that array apart. Instead of subscripting into the array and saying, give me the first element, array sub 0, and give me the second element, array sub 1, I can just deconstruct it like this. It's a very clean way to pull a thing apart. Okay, so one more place where we can use pattern matching is in a for loop. All right, so here's a for loop. If you take the course with us, we will already have discussed this in great detail. So here's a case where I'm looping over a Java system, system.getProperties, which returns a Java util properties. Up here, this little bit in blue is more Scala magic that automatically allows us, basically, to map a properties object automatically into a Scala map. And then we can loop over that map. Now, what is a map? A map is a set of key value pairs. So when you loop over a map in Scala, the map class just feeds you back these key value pairs. But I can deconstruct those on the fly in the for loop here. This is a form of the pattern matching syntax. So that I don't have to say, okay, now I've got this tuple, let me take it apart. It can be taken apart right here in the for loop. This can also be used to do pattern matching on the fly. So I can say, hey, loop over these properties as a map, but only give me keys and values where the value is the empty string. All right, so this is an implied filter because of the pattern matching here. And this is exactly the same as if I had used a guard condition in the bottom here. Hey, loop over the map, assign the key to K, the value to V, but only if V is equal to the empty string. Both of these things are equivalent. And this first one in the middle here works because of pattern matching. So what you should take away from this is that pattern matching is an extremely powerful feature in this language. Provides you, the programmer, with an amazing amount of power to do all kinds of matches with a very concise and very readable syntax. And because it's all just syntactic sugar for unapply and unapply seek, as you build out your own classes, you can build pattern matching into them and they will automatically work with these matches. It's an amazing feature, and you will not find this feature in Java. For my part, when I have to go back and program Java, I really miss this feature. Now, this is just the tiniest bit of what the NewCircle Scala course will cover. So if you want to find more interesting, cool, powerful features that this language provides, check out some of the NewCircle Scala offerings. And that's our introduction to pattern matching for today.